Assalamualaikum warahmatullahi wabarakatuh. My name Achmad Hashfi Mawarid, study number 83, Unit 7, Heat Flow, Thermodynamic. In almost any chemical process plant, materials are constantly being heated or cooled. This is done for a variety of reasons. As we have seen in the previous unit, it is often necessary to heat viscous materials in order to make them flow easily. Another reason for heating is to melt solids or to change liquids into vapors by boiling them. Chemicals may be heated to increase the speed of a chemical reaction or to make it occur at all. A handy rule known to most chemical engineers is that a 10 Celsius degrees increase in temperatures will approximately double the rate of most reactions, but some chemical reactions give off heat as they occur. Such materials generally require cooling if the reaction is to be properly controlled. Cooling is also required to change or condense vapors into liquid and to freeze liquids into solids. In many reactions, the temperature influence the product being formed. Consequently, the temperature must be controlled so that the materials remain at the temperature that produce the highest yield of the most desired product. The science concerned with the generation and transfer of heat is called thermodynamics. The subject is emphasized in every chemical engineer's education. In almost all chemical process plants, heat is generated by the burning of fossil fuels, coal, oil, or natural gas. The heat give the heat given off by the burning fuel may be used directly, but most often it's used to generate steam which is piped to the place where heat is needed. The easiest way of heating a liquid with steam is to bubble the steam directly into the liquid. For example, steam can be supplied to a pipe immersed in the liquid. A number of small holes are drilled in the pipe to allow the steam to escape in small bubbles. Such a device is called a sparger. Sparger. The bubbles of steam rise up, transferring heat to the liquid and mixing it at the same time. During this process, some or all of the steam condense into water, which remain in the liquid being heated. Consequently, this kind of heating, called direct injection of steam, can be used only if the pressure of condensed water is not a problem. In most cases, direct injection of steam is impossible. The steam and the liquid to be heated must be kept separate. To heat the liquid without direct contact, a piece of equipment called a heat exchanger is used. It has a barrier of some solid material between the heating medium and the material to be heated. Many varieties have been invented, but by far the most common type is the shell and tube heat exchanger. The material to be heated may be tube-side or pass through the tubes, with the steam cell side or outside the tubes. It's possible to have steam on the top side and the other material on the shell side, but this is uncommon. Usually the steam is on the shell side so that it condenses on the outside of the tubes. The resulting water falls to the bottom of the shell where it's allowed to pass out of the heat exchanger by means of a special device called a steam trap. This is steam trap designed to permit the escape of the condensate or water condensed from the steam, while trapping the steam or preventing it from escaping. At normal atmospheric pressure, water boils at 200 and 212 Fahrenheit degrees or 100 Celsius degrees, and its steam is at the same time temperature. The pressure is increased, the boiling point of the water or and the temperature of the steam being produced is rise. To use high temperature steam, it is necessary to design and build all equipment to withstand the high pressure associated with the high temperatures. High pressure equipment is expensive sometimes to provide the high temperatures without having to deal with high pressures. Chemical engineers use special heat transfer liquid for heating. These are materials that remain liquid at much higher temperature than water. Two common heat transfer liquids are known as Deuterium A and Deuterium E. Deuterium is a trademark of the Dow Chemical Company, which manufactures and market the product. Deuterium A is a mixture of two chemicals, diphenyl and diphenyl oxide. It boils at about 450 Fahrenheit degrees or 230 Celsius degrees. The term E is O-dichlorobenzene, which boils at about 300 Fahrenheit degrees or 130 Celsius degrees. Some minerals oils are also sold for use as heat transfer liquid at temperatures ranging to about 600 Fahrenheit degrees or 315 Celsius degrees, but most tend to deteriorate if kept at high temperature for a long time. Or the daughter material are very stable, even after many years of use if used at high temperatures. If a material is to be cooled, a shell and tube heat exchanger can also be used. The cooling medium is normally water, chilled water, or cold brine. As mentioned earlier, brine, or a solution of salt in water, is used because it freezes at a lower temperature than pure water. Sometimes liquids are cooled by circulating them through pipes exposed to the atmosphere. This is called an air-cooled heat exchanger. The cooling process is speed if a fan is used to blow cool air rapidly over the tubes. When a shell and tube heat exchanger is used for cooling, the material to be cooled may be either on the tube side or the shell side. With the cooling medium on the other side, if one of the two liquids is more corrosive than the other, brine, for example, can be corrosive. It usually on the tube side. The tubes can be made of a corrosion-resistant material. With the cheaper materials, for the shell. If a corrosive material is used on the shell side in contact with both the inner surface of the shell and the outer surface of the tubes, both the tubes and shell must be able to withstand corrosion. It's possible to operate shell and tube heat exchanger in either the horizontal or vertical, but horizontal exchanger are most common. When steam is used for heating, it's always introduced through the upper opening or nozzle in the shell so that the lower opening can be used for draining condensate. If a pool of condensate builds up such an exchanger, are usually due to a malfunctioning or wrongly sized stream trap and submerge some of the tubes, the heat transfer suffers because condensing steam transfer heat more rapidly than does hot water. When a liquid is used on the cell side, it's always introduced through the lower nozzle and withdrawn through the upper nozzle. In this way, the engineer can be assured that the exchanger remains full, with the liquid surrounding all the tubes. Cell and tube heat exchanger are so widely used that they are available as stock items from many manufacturers. There are a number of standard designs used throughout the industry. These are detailed in the publication of the Tubular Exchange Manufacturers Association, or TEMA, and are therefore called the TEMA standard. However, no group of standard exchangers could fulfill all needs. So many exchangers are custom designed and manufactured. The size of the shell and tube heat exchanger need for any particular job depends mainly on the amount of heat to be transferred and the volume of fluid to be handled. The calculations are learned in college by most chemical engineers, but computer programs now do them automatically. Although most heating is done with steam or heat transfer liquids such as therm, other liquid may also be used as the heating medium. This this is most commonly done when there is one liquid stream in a blank that needs to be heated and another needs to be cooled. Passing both stream Passing both streams through the same heat exchanger will accomplish both objectives simultaneously. When a heat exchanger is used with liquid on both the tube side and the shell side, the liquids are usually made to flow in opposite direction. The direction this is the direction, opposite direction. This is known as the counter-current flow. Of what materials flow in the same direction of the flow is called co-current. Co-current. Sometimes a heat exchanger is designed to chill the vapors of a substance and condense it into a liquid. A special exchanger of this kind is called a condenser because of the way it's used. Although it's not too different from any other exchanger. When used, condensers, shell and tube heat exchanger are often mounted vertically. Commonly, when a fluid flows in a pipe, it moves fast at the center of the pipe and slowest at the wall because of friction between the pipe and the flow liquid. When fluid flows relatively slowly, there can be a very thick layer of fluid near the pipe wall that hardly moves at all. This condition is known as laminar flow. And makes for poor heat transfer because the static layer of fluid near the wall acts as a resistance to the movement of heat. When fluid is flowing rapidly, swirls and eddies are set up that reduce reduce the thickness of the static layer near the pipe wall, and thereby decrease the resistance to the movement of heat, or increase the rate of heat transfer. This kind of agitated flow is known as turbulent flow. Turbulent flow. The speed at which laminar flow changed to turbulent flow was investigated early in this century by an experimenter named Osborne Reynolds. He worked out he worked out relationship He worked out a relationship known as the Reynolds number that helps to determine the transition from laminar to turbulent flow. The Reynolds number is found by multiplying the inside diameter of the pipe by the fluid velocity and the fluid density, and then dividing by the fluid viscosity. The unit the units used for the variable are selected so that all the units cancel out. Hence, but the Reynolds number is known as a dimensionless number, or for example, diameter in centimeters, velocity in centimeters per second, density in grams per cubic centimeter, and viscosity in grams per centimeter second. When the Reynolds number is less than 2,100, flow is always laminar. When it is above 4,000, flow is always turbulent. Between Reynolds number of 2,100 and 400, the flow may be either laminar or turbulent, depending on condition at the entrance of the pipe and on the distance downstream from the entrance. Discussion. Thank you. Assalamualaikum warahmatullahi wabarakatuh.